Okay, guys, the next lesson for the test would be counting principle and just focusing on certain parts of counting principle. So it's not the entirety of probability, but this is just one part, right? So we're going to start with the fundamental counting principles. We're going to talk about arrangements with and without repetition, and we're going to just talk about restricted positions, and that's where we're going to end. Um, that's the part what we're going to deal with. I don't think it's too difficult. I don't think you guys are gonna struggle, but I would prefer to do the full lesson with you guys. So let's see how it goes, right? What I'm going to cover in this lesson is multiplication, counting principles, arrangements of codes, that's with digits and non-repetition, restricted positions, so a problem like a leading digit or odd or even number, and some sort of linking counting to probability, right? This is quite simple. I think you guys will manage, but the fundamental counting principle, right? If I want you guys, let's try and label. Let's call it fundamental. The fundamental counting principle. Now I know you guys struggled a bit with this, but I mean it's not too bad. See, if one choice can be made in many ways and completely independently, and then a second choice can be made in maybe different ways, then the two choices together can be made when we take choice one times choice two. And this is the single idea between uh, every single counting question that you'll do. So we'll take something like Shiloh has three shirts. She has a red shirt, a green shirt, and a blue shirt. And Shiloh has two pants. She has a jeans and I don't know, tracksuit. Jeans and tracksuit. Jeans and tracksuit. Now this is a tree diagram and it's okay. It works for very small choices, maybe two choices, three choices. But as you go to 4 branches and 5 branches and 6 branches and 7 branches, then you guys are going to suffer because it's hard to draw, but there's too many ways to do it. So when it comes to bigger choices, like Shiloh has 3 choices of a shirt, but she got 2 choices for pants. So the number of outcomes that we can get is technically she only gets 6 outfits. Okay. Now this is 6 outfits only. Okay. So that's basically what it is. Now, if we look at example 1, I'll go with example 1. Let's start with Zanele has okay, same question. Um, Zanele has 4 shirts and 3 pairs of pants. How many different outfits can she put together? So basically, there's only 2 choices. She has 4 shirts and she has 3 pants. So all together, no matter what happens, she can only put together 12 outfits. That's the rule of the counting principle. 12 different outfits. Now, this slot method, for any counting problem, all you have to do is draw one slot for every decision, right? That has to be filled. You write the number of available options above each slot, and then you multiply the numbers, right? And this works perfectly for outputs, number plates, pins, seating arrangements. Basically, every single question you can think of, the slot method works very well. Now, let's go with arrangements when repetition is allowed. Okay? So the counting principle works like this. When repetition is allowed, it is quite simple to deal with because now the guide that I was teaching you guys, my proper guide is 18, 19 pages. This is only 7. So it's very short. There's some stuff that's missing from here, but it's okay for a test. Arrangements when repetition is allowed. So when repetition is allowed, every slot has the same full set of options. No matter what was chosen in the earlier slots, because the digit or the letter will always be used again. How many three-digit codes can be formed but using 0 to 9? And if the digits may be repeated, then that's fine. So let's let's put the slot method. Now, guys, I'm not going to go and draw each choice, but basically, this is, okay, let me do it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Guys, all of this has 10 options. 10 times 10 times 10. Now, don't confuse 10 times 10 times 10 by factorial because it's different. This is 1,000 because that will be another lesson. But I've seen people tell me, hey, Keegan, this is factorial. No, it's not. So take your time and we can answer all of it, but it's quite simple. This is 1,000, right? So the shortcut formula, whenever any repetition is allowed, all you have to do is take the n value. So if there's 10 options, you put it as 10. And if there's digits, maybe there's three slots, put 10 to 3. But that's only when repetition is allowed. Now, when we have arrangements without repetition, right? Arrangements without repetition changes because there is a different part that we need to deal with. And I think it's quite simple. I think it's quite simple. So arrangements without repetition. So it's the same thing. We have a square or mine might be a rectangle. But guys, I'm going to write because I want you guys to see something. But on the first choice, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't mean I'm taking out 0. It just means that if we put one choice here, there's 10 choices. In the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 choices. Let's take out that one. And the next one, 2, 3, 4, 5, 6, 7, 8, 9. And that's 8 choices. Now, guys, this 1, 2, 3, 4 doesn't represent the numbers. It represents the number of choices that you have. So 10 times 9 times 8, and that equals to 720. Okay. Now, if we deal with this, that's the three factors of 10 times 9 times 8. That's the first three factors of 10 factorial, right? 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In grade 12, in all the NSE papers, except, they can accept the working, you can use the slot method. You don't need to go and memorize any formulas, or you don't need to memorize any of the other parts because they are formulas. They are permutation formulas, stuff that looks like this. But you don't need to use it. If you want to, go for it. I'm sure that's fine with me. But I mean, you don't need it. You can use the slot method and deal with it quite simply. We're going to go with a 10-digit code problem. The next one is about question part is side by side. The 10-digit problem. Now, you guys, if you're giving me faulty scopes, and you don't tell me what's coming out and just tell me 10-digit problem, I just have to teach you all as is. Right? The example is a gym issues a 5-digit locker code. Right? So let's start with a gym issues a 5-digit locker code. Right? And with this 5-digit locker code, each digit is chosen 0 to 9. Okay? Each digit is chosen from 0 to 9. Okay? Now, if they repeat, guys, question A, I'm not going to write fully, but if you are allowed to repeat digits, how many possible codes could you have? So use the slot method. 1, 2, 3, 4, 5. If you're allowed to repeat digits, no matter what happens, that's 10, 10, 10, 10, 10. And we can use the 10 to 5 formula if you want, and that should be 100,000 codes. But question B, if we're not allowed to repeat. So if we're not allowed to repeat, now the slot method works even better because it's still simple. 1, 2, 3, 4, 5. Guys, the first code has 10, then 9, 8, 7, 6. And if you multiply all of this, that's 300, oh, that's 30,240 actually. That's all there is for this question. We don't need to use any formulas. We don't need to panic. But notice that repetition will always give a larger value, right? Because if you forbid them to repeat, or if you tell them they're not allowed to repeat, you're lowering the number of options that they can do, right? But other than that, if you ever see a repeat value being smaller than a non-repeat value, then you kind of messed up. But let's go with the next one. So this one would be restricted slots. Okay, so restricted slots are important. You see, the restricted slots, the rule is fill those slots first. You see, many exam questions are going to add some sort of restriction. Maybe the parent, maybe even, maybe only red, or the code can't start with 0, or it must be even. It must have some sort of digit 1, 2, 3, 4. The best way you can do is find out which slot is restricted and deal with that first. And that's the best thing you can do. It's always the best way that you can deal with. So we find out the restricted slots first. Let's deal with this one. And then we deal with it. So let me show you what I mean, right? So how many 5-digit codes can be formed from 0 to 9 with no digit repeated, and if the code may not start with 0? Okay, guys. So let's start here, right? I'll show you guys something that's 1, 2, 3, 4, and 5. Guys, realistically, the first code can't be 0. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It can't be 0, right? So this is our restricted slot because they told us the first one can't be 0. But we know it can be 9 because there's 9 other options. But now this slot can be 0, but it can't be 1 because we can't repeat the choice that we made. 2, 3, 4, 5, 6, 7, 8, 9. So this is also 9. Let's just take out the next one, right? Or it doesn't matter what you take out, right? And then we continue. The next one's going to be 8, 7, 6. And if you continue in that manner, it's going to be 8, 7, 6. And all of this nonsense, when you multiply it with a counting principle, it should equal to 27,216. And that's all. The restricted slots are the easiest ones to fill first because we know what's supposed to go there. So deal with those ones first. Okay, guys, this is the counting principle plus probability. So the counting question is often followed by some sort of probability question. It's always using the same numbers. And you can just remember a really basic formula. Whatever event they're talking about is equal to the number of favorable outcomes over the total number of possible outcomes. So this is the one that We generally end up calculating with a counting principle, and then they give us something, right? Let's start. A five-digit gym locker code is generated randomly, completely at random. Choosing each digit from 0 to 9 with repetition allowed. So, guys, it's a five-digit code. We're doing repetition is allowed. They gave us an answer, but most likely they would not give us the answer in exam. We know this is 10, 10, 10, 10, 10, which equals to 100,000. They would not give you this in the exam, right? Calculate the possible probability that a randomly generated code has no repeated digits. Okay. So now they mean no repeated digits. How do we get no repeated digits? So this is the total. If there's no repeated digits, now we have to think about it a little bit differently because we did this question. I created this question straight from the other one as well. But this is going to be 10, 9, 8, 7, 6. And that equals to 30,240. And then the probability of no repeat would be equal to 32,000. Ooh, nonsense. 30,240 all over 100,000. And you could times it by 100 if you want, but it doesn't really matter. 0.3024 or 30.24%. And that's all there is to this question. Any exam tips for this would be the total possible outcomes for this kind of probability question is almost always, it's always with the repetition count, right? So every code is equally, I would say, likely to be generated. And make sure that the denominator matches the actual, the random process that's described in the question. Just to make sure, I'm going to give one more part, the common errors. And yeah, I'll give you some practice questions, and then that's all there is for this part. Remember, this is just the counting principle part. It's just for the test. So it's not like it's level 4. The level 4 questions are more in my other documents. So yeah, let me sort this out and we are done. Okay, and then if you wanted the answers, which I'm sure you guys do, these are the answers, and yeah, good luck, guys.